Yeah, hi everyone, and thanks for joining this talk. This is my very first conference talk, so let's see how this works out. Um, as you might have guessed from the title, I will be talking today about custom resources of Kubernetes and the way to use it to extend the functionality of your Kubernetes cluster. But before that, I would like to introduce myself and my employer. I work for a company called BEDAG Informatik AG, or short BEDAG. We are located in Bern, Switzerland, and I assume no one here has ever heard of us because we do mostly government stuff, and more specifically, we do government stuff for the canton of Bern. But if you live in Bern, well, if you do your tax declaration online, you will be using systems developed and operated by us. We also do stuff for hospitals, the police, public transportation, you name it. As for me, I'm responsible for our Kubernetes platform. That means I have to do all the formal stuff regarding platform definitions. I have to keep it running together with colleagues. But also, and more interestingly, I'm responsible for also developing additional tools on and for our Kubernetes clusters. This means, for example, I work on deploy pipelines, scripts and tools to deploy applications, and stuff like this here, extending Kubernetes itself. So with that out of the way, let's get to the technical details. I will skip the customary question of who of you is using Kubernetes because, well, if you don't, the only thing I can tell you today is use Kubernetes so you can use what I will be telling you. So let's get started. What do we want to achieve? The actual goal of the talk is to show you a way to create your very own Kubernetes resources that look like, behave like, and can be used like every other Kubernetes resource you know and hopefully love. So as you can see in this small example here, we have a resource type, my resource. I assume you have never heard of it before because it doesn't exist yet. And you can just create it with kubectl or whatever means you use to create resources. You can delete it, you can list it, you can manipulate it, whatever you have to do and want to do. But why would you like to do that? Well, the best aspect of this would be to say you can create self-service type of resources for your for your users of your cluster. For example, if you want to have every user to be able to create their own object store, S3 compatible object store. You could create a custom resource that does exactly that. And then you can add roles and limits, whatever you need to work on this resource, which behaves like every other one. There are other ways to achieve similar goals which have well, disadvantages. For example, you could use Helm to allow users to deploy their own Helm charts. But if you would like to do this cluster-wide, well, you would have to give all your users access to a central Helm instance, which means they can control your whole cluster, which is, well, mostly not what you want. So, how do we get to this goal? Well, we need 3 parts. The first one is a resource definition, making your new resource known to Kubernetes. That's it, nothing more to that one. Some logic to do something, because just having Kubernetes know about your resource is not really useful. You want to actually something to happen when you create it. And the last point is to make the logic and the definition stick together and work in unison so that, well, you can do whatever you want. So let's start with the easiest of these 3 parts. The resource definition. For that, there's a native Kubernetes resource that's called CustomResourceDefinition. And that is used to tell Kubernetes about your new resource. And a resource, as you hopefully know, consists of 3 parts. That's an API group, a version, and a kind, or what you normally use, a name. For example, deployments are in the API group. Apps have a version of 1 and, well, have a kind of deployment. So the custom resource is used to introduce these 3 parts to Kubernetes. So in this case, we create a resource definition for an API group called stable.mycompany.com that has version 1 and a kind of my resource. And that's actually it. If you deploy this to Kubernetes, you can actually start creating resources of the kind my resource. It won't do you any good because nothing would happen. Kubernetes would just say, well, thanks, I've created the resource, but there's no logic associated to it. But I'm going ahead of myself. Let's create a big picture and add the different pieces to it. So we start small with a lot of nothing. We have our custom resource definition and the API which we used to create it. Let's get over to the next part, the logic part. For that, we use a tool called Kubeless. And Kubeless is a so-called function as a service framework. If you have never heard of this term, it's basically a framework where you can say, well, here's my code, make it work as a web service. That's a very oversimplified description of what function as a service is, but for our case, for our use case, that's enough. So we use Kubeless to create our actual resource logic in form of a web service. So how does it look like? How do we do that? Well, again, as everything in Kubernetes, we use a Kubernetes resource. In this case, a function. This is a normal Kubernetes function resource header. We have, again, an API version, a kind, and some metadata. In addition to that, we have to tell Kubeless what actual runtime we want our code to be executed in. In this example, I just use Python 2.7. But you could also use Ruby, Go, Java, and a bunch of other runtimes. We have to also tell it which function to call, so it knows, well, actually what function to call. We also have to give it a checksum of this function. Kubeless uses this to ensure that the code it is executing is actually the code that you want it to execute. It's just a safety measure. We also have to give it a content type, in this case text, because we inline the function. You could also provide it in form of a zip file, but for this example, just stick with a simple one. And we have to provide the actual function. In this case, a simple 2-line Python hello world example. What else did you expect? The interesting part here is the parameters. The parameters are provided by Kubeless when your web service is called. And the most important one is the event one with a data field, which actually contains the parameters given to your function in JSON format, which Kubeless then converts in whatever native data format your language has. So in this case, we expect our data to contain a field called world, and then just print it. So how does it look like? Well, we can just use curl to test our function. In this case, we use curl to call it with some JSON data where the world field just contains Kubernetes, and, well, call our function in the test namespace, and we get what we expect, hello Kubernetes. So that's our function. I hope you can imagine, based on this, you can implement a lot of logic with that, a lot of code, depending on what you actually need. So let's add this to our big picture. So now we have the function on our right side. On our left side, still the API with the custom resource definition. On the right side, our logic in form of a kubeless function, and a big nothing in the middle. That's the actual tricky part, because now we have to combine our function, our logic, with our custom resource definition. So let's get to the last part, to the magic part. And as everything in the area of cloud has to be called as a service, let's coin the term magic as a service. Well, why magic? Because I think it was Arthur C. Clarke, correct me if I'm wrong, who said, every sufficient enough technology is indistinguishable from magic. I think that can apply here. Just to give you an example. The code for the stateful set, the native stateful set resource of Kubernetes, is around 9,000 lines of Go code. You can re-implement stateful sets with Metacontroller. with around 200 lines of JavaScript. They actually did that. You can check the code for that on their example GitHub repository. And that's the main thing it does, is it encapsulates a lot of API magic behind an easy-to-use Kubernetes native interface that we can just use. And we don't have to care about all the messy details. So yeah, how do we do that? Again, we use a Kubernetes resource. Everything is a Kubernetes resource. The normal header, as expected, metadata, kind, API version. And now the spec. We first have to tell it on what parent resource it has to listen. This is our custom resource we just defined, in this case, stable.mycompany.com, my resource version 1. We also have to tell it what child resource it has to create, or what it should expect that will be created. In this case, I just used pods. We also have to tell it what it should do when the resource changes. So for example, our parent resource changes, we add some configuration. What happens to the child resources when some parameters change there? In this case, we tell it to delete the pods and create them anew. You could also say in place, which means it just updates the resource, but well, for pods that's not really useful. We also have to tell it how to handle selectors. So I have to assume you all know how a stateful set or deployment is created, because there you need selectors. You have to tell a deployment how to associate the pods it creates with itself, so it knows what it's managed. That's a selector. You have to do this here too, except you don't want to. Then you can tell Metacontroller to handle selectors itself, and the resource you created behaves more like a job, where every instance of the resource creates a new instance. And lastly, we have to tell it about where to find the logic, the actual webhook implementing the logic. In this case, in this example, not really useful example, we tell it, well, our test function. And this now ties our two pieces together. It connects our custom resource definition with our logic. But we still have to know how these two connect together. Well, how does the communication look like? When you create a parent resource, Metacontroller notices that and provides your web service with a call containing the complete parent resource, all data you created with kubectl, apply, or whatever, and a list of currently existing children, or an empty list if no children currently exist. That's what your function gets, and that's actually all it needs to know. What it has to return to Metacontroller in the web request is firstly a status. That's just a field that you can fill with whatever you want it to be, because if you think of pods and you do a kubectl describe, you get a status field also. So that's a way to communicate with your users, and exactly that's this. It's just a way to communicate with your users what's happening with your resource. And additionally, you have to return a list of children, and that's the state that you want Metacontroller to create. What happens with this list? Well, Metacontroller ensures that every resource contained in this list and not in the list of currently existing children gets created. It also ensures that every child not in this list, but in the list of currently existing children, gets deleted, and every child that differs gets updated. And that actually is the whole magic of Metacontroller. It ensures that this whole reconciliation loop is actually done in a reliable fashion. And all you have to think about is how to process the JSON that you get and how to create the JSONs that Metacontroller needs to get, to get its work done. So let's add this to our big picture. Now we have filled the gap in the middle. We have on the right our logic, on the left our resource definition, and we have our Metacontroller in the middle, tying both neatly together. So how does such a request a whole loop of creating resource look like? Well, here's a picture again. And let's start with our user creating a new instance of our custom resource, my resource, or however you want to call it, with a kubectl apply on some YAML file. This gets notified by the API, which in turn ensures that Metacontroller gets notified because it watches on the parent resources, so your custom resource tab. Metacontroller then calls your function with the JSON structure I just have shown you. So it contains, in the initial statement, just the parent and nothing in the child list. Your code then does whatever processing it has to do and returns a JSON structure containing the status and the list of children. Metacontroller then uses this information to do whatever API requests are necessary to create these children, which in turn results in these children being created. This whole process of watching, notification, web request, response, API calls, and so on continues in perpetuity. Every time something changes, this gets reconciled by Metacontroller. So, how does it look like actually in reality? Well, let's have a demo. And as this is my first conference, and I'm not brave enough to do a live demo, I pre-recorded this. So, let's have a look at this. So, let's first list the files I'm going to use. And no, it's not a video, it's a terminal capture. So you can select and copy and paste if you want to do that. So let's start with the resources I just have shown you. We have a function, a CRD, a composite controller. I also need a namespace because, well, everything in Kubernetes needs more or less a namespace. This is what I generate first, and this will be our logic behind everything. And then I will create the actual, well, instances of my custom resource. What this custom resource will be, although I will not go into the details there, is a min.io instance. And if you have never heard of this software, it's a small tool that allows you to create an Amazon S3 compatible object store. It's easy to use and a nice example to use in this case. So let's get started. I will show the different resources that will be created. And yeah, well, it's a namespace. Nothing new here, I hope. Let's just create this. So next up is the custom resource definition. This one will be a little bit, well, no, it will not. So here you see, again, we create an object store.unstable.mycompany.com, version v1 alpha 1, and we call our kind object store. That's the new resource type I will be introducing to Kubernetes. So let's see if this works, and as you might have guessed, it will. So Kubernetes doesn't complain, it just tells it, well, I created the new type. Next up, I will create the function. I will not show you the whole function because, well, describing 160 lines or so of Ruby code won't be very fun, I think. You can have a look at this in all its glory in the GitHub of this project, so you can just have a look on it later. I will be using Ruby here, and yeah, everything is here that you need. And let's create it. The function itself will be just called controller. Again, I assume Kubernetes won't complain. So last up, and this one will be a little bit more complex than the example I used previously, is the composite controller. Because instead of just creating one pods as children, I actually need to create some more resources. So let's start with the easy part. we reference our parent resource, and we reference the just created kubeless function in the object store namespace, and it's called controller. What we also do is, this time we want to handle selectors ourselves. So we want to say, well, you have to listen for these pods and these resources with these labels. And we also create different types of child resources, services, a deployment, persistent volume claims, and so on. That actually makes this example a little bit more complex and a little bit more longer than what I have shown you. But functionally, it's the same. So again, Kubernetes doesn't complain. So now we have everything we need. We have a custom resource definition, we have a function, we have a composite controller tying everything together. So how does it look in the namespace? Well, the only thing you will see are the resources actually created by Kubeless. And Kubeless creates a deployment, which in turn creates a replica set, a pod, and a service. So yeah, here you can see we have a function, and it's running. So next up, let's actually use this custom resource to create an instance of an object store. Again, I need a namespace for that, so let's just create one. So now comes the interesting part. The custom resource, the instance of the custom resource. So, and you might have never seen such a resource before because, well, it doesn't exist anywhere else. And the different fields, the spec of this resource is actually not defined anywhere. My code just expects that I do the right thing here. But I have decided, well, again, we need a selector. I just said that. And I give it an image, just a Docker image where I wanted to use it as a base. And I give it, as we create something involving storage, some details about the storage I wanted to use. In this case, a storage class and a size. So based on this information, I now hope that our code will create an instance of our object store that we actually can use. So again, it was created successfully. And now let's have a look at the my project namespace we just created. Well, we created it, so it was empty just a moment before, so let's see how it looks now. And as you can see, it now contains a little bit more than just the resource I just created. It contains a deployment, a service, and so on. And this actually is what, well, the logic does, and in combination with Metacontroller. So it handed over the parent resource, which contained the 8 GB for the persistent volume, the deployment, and so on, and then returned a list of Kubernetes resources, the ones you see here. And to get back to our initial goal, I promised that you can use your custom resource as any other resource. So let's start by just listing it. And what we will see now is, well, yes, we have a resource, my object store, of the type object store that we just created. And we can also delete it, which is equally important. And what we expect to see after we delete this resource is that actually the namespace will be empty again. So Metacontroller cleans up after itself. And this is actually something your code doesn't have to handle. It never sees that the resource gets deleted. So, as you can see, it behaves as expected, and depending on your imagination, you can do all sorts of things and all sorts of complicated stuff. And that actually concludes my presentation. Thank you for listening. I hope I was able to give you some new ideas on what to do with your Kubernetes cluster. If you want to contact me, well, I'm a little bit old school. I have no Twitter or something like this. I hope someone is still using email, so please contact me or just speak to me on the conference. I will be around here till tomorrow. And just as a suggestion, as a follow-up, the next talk will be about Kudo. And I think this will go very neatly with what I have shown you, because these two projects go very neatly together. So yeah, I've put the links at the last slide, which you can use when you get the presentation from the OSDC team. And yeah, thank you.
Thank you very much. So you made it, first talk. Are there any questions?
So what is there in the 140 lines of Ruby code that is there? That's the first question. And the second question is, for what use cases do you create your own custom resource?
Okay, so can you please repeat the first question?
So the first, in the function that you created,
Yes.
you told that there's 140 lines of Ruby code.
Yeah.
Yeah. So what was that for?
The Ruby code, what it actually does, it just
Yeah.
creates some hashes representing the Kubernetes resources.
Okay.
There's
Okay,
nothing.
That is only for returning back
yes,
the response.
I
right?
just
Yeah.
create the data, so the YAML structures, nothing more. But as you can expect, if you create 4 or 5 Kubernetes resources that are quite some amount of lines,
Right.
but there's no trickery in there. It's just the last statement is a return statement containing this data structure to JSON. That's
Sure.
it,
Okay,
nothing more.
okay.
And the second one is what are we using custom resources for? Well, we created a concept of multi-tenancy based on this. So we want our users to have a set of namespaces all managed by the same service account and the same tiller. That was the initial use case we had. We implemented this with Helm. We were not very satisfied with that, and we then implemented it with custom resources, which works far better.
Any more questions? We
I
are
think
running
we're-
out of time a little,
Okay,
but
same.
okay, I'm sorry.
The question is already answered. The next one is in front of you.
Can you basically do the same thing as by writing your own operator, or are there any limitations?
An operator does a little bit more than just a custom resource, because an operator implements a life cycle that belongs to the software you are deploying. So that's why I said, listen to the next talk, the one with Kudo, because with Kudo, from what I gathered, I have to see the talk myself, is you can create operators based on resources, and you can then combine this with your own custom resources. So if you have a special lifecycle, for example, your object store, you can combine this to an operator. But a custom resource on the way Metacontroller creates it or allows it to create is a more basic type. But you can use this then in an operator to create more complex systems that actually cover the lifecycle of a whole application.
So we have time for one final question. Anyone? No one? Okay. So then I say thanks again.